Perfect. So good morning, everyone. I'm Jonathan Eyre, and I'm a Senior Technical Fellow at the Advanced Manufacturing Research Centre. Ontologies often get referenced on the Gemini Call, and I thought it was time to demystify how you layer them together, in particular looking through a piece of work I've already presented on the Gemini Call, looking at a piece of work done with the Department for Transport. So a little bit of framing. We've used information systems for decades, and it was fine in quotations, if you like, when they were individual systems and they didn't need to talk to each other. But over time, what's happened is we've connected them together and wanted more and more connections between these systems. Ultimately, to be frank, it's become a big mess, and we don't have interoperability, and there's point-to-point solutions happening between all of these systems. So really what we're trying to explore is what is the framework needed across all of these systems now. So when quantum comes along, and is already coming along, or new technologies are being approached, they can be integrated rather than reworking whole systems if we needed to change one of these systems. Now, there's lots of work already done in this space, and actually if you look across that domain, there's lots of different models, different architectural diagrams, and different ways of approaching it. Now, I'm not going to spend lots of time, you'll be glad to hear, explaining each of these in detail. What I do just want to highlight is that they are all saying there should be a foundation data model or some form of top-level ontology needed for all of these. There's hundreds of different ones, but they do all establish that a fundamental approach is needed to have some level of interoperability as we move forward. Now, one of the main approaches being done in the UK is Borrow. And Borrow is a piece of work happened years ago by Chris Partridge and still actively working in this space. And it breaks it down to these four things. And we are categorically trying to handle every single object with full extensibility. And there are three fundamental disjoint categories. There are the individuals, things that do definitely exist. There are sets of these individuals and sets in general, as well as relations between individuals and sets, as well as sets of those relations. So they all work together. But for you to have anything in your data model, it must be just one of these things. And that really sets up for extensibility from a perspective that we're certainly looking at within the UK. There is lots of work happening where people are smushing together different foundation ontologies. So they're using a bit of UFO or GFO or BFO or IES or whatever else. And they are really disjoint. You can't just do that from an ontology perspective. So this is a really heavyweight commitment that will give you interoperability as we move down. But this is that very much top level basic things. Starts getting to philosophy a little bit, but fundamental approach for what we're doing. Now, as we're moving up, if you like, depending on which way you look around of it, you start to get into foundation data models. So building on top of Borrow, you've got lots of other models coming out. IES4, as what is version 4, has one approach coming from this based on Borrow, and you can start to see how they're building it up. We have the foundational stuff of entities, states, relations, attributes, measures, and time. And then the bit that people often want to just jump straight into is person, organization, location, travel, etc. So this is the language that people want to start to use, but with a consistent framework behind it all, so we've got consistent representation. Now, for anyone interested, there are lots of other foundation data models. Here is just one particular framework produced by the Centre for Digital Build Britain, and certainly worth looking at if you want to see where you're coming out in terms of adopting a foundation data model. Now, built on these sort of foundational and key concepts that you find in these foundations, there's lots of language that isn't captured right at the top. This is often what's clumped in terms of reference data libraries. So domain-specific concepts. For us, when we're doing the work with Department for Transport and continuing with, is looking at actually some of the transport things. We can't expect the key concepts to capture all the different types of locomotive and vehicles, etc. But there is vehicle defined, and we can extend down, built upon the reference of Borrow and other commitments coming down. So what you end up doing is producing these local extensions. Lots of people look for 2 or 3 layers, but there is no limit. It's just arbitrarily work down these local extensions to the level of detail you need to for your particular use case. So that means for us, we've got this transport ontology, building on the foundation, extracting and building on some of the key concepts. Any of the domains concepts already in IES, we can just use as well. Again, aiming for simplicity here, with all of the extensions being made. So let's just flesh that out and see how that forms. So we've committed to borrow at the top as that top level ontology. And then we have IES4 being our foundation data model. And what starts to happen is then, through the analysis we've been doing, looking at the process we've used with Be Clearer and some of those, we've analyzed active data models and started to pull out these different domains. And what we've realized is, by looking through all of these different data sources, there's actually a bit missing. And that's what we've extracted out, is this transport core. So what's all the network models, or what's the general concepts needed across all of these domains, as pulling up this sort of sandwich or stack of language that people like to use. What that also means is we've been able to decouple particular reference data libraries. So road rail, so level crossings, it needs and has a dependency on road and rail. But if we had that part of both, you would have to pull in every single domain language at once. So we've kept them decoupled, so you can just do road analysis or just do rail analysis. But if you want to use both and you're doing a little bit of road rail, you can pull in all three to do your analysis at once. Now, this is just what we've done for this particular program, and it is slightly artificial with where you cause that divide. But these extensions just keep being made as far as possible. Ideally, you're abstracting as high as possible so other people can do the analysis in a similar way, in a consistent way to yourself. So aspects like the network model should be fairly high, because then if other people have network models or system models, you have the interoperability between those systems as well. So just to spell it out a little bit, we have the top level ontology, we have the foundation data model, and we have all of these reference data libraries having dependencies as it works back up the tree, but all of these sort of decouplings as far as possible. So last little plug, there is ongoing work still happening with the Department for Transport, and the rail and maritime reference data libraries is available for feedback shortly. So please get in touch. You can see in the background there some work by the OntoKai platform by Chiasm, and who we're continuing to work with for this project. So please get in touch if you work in the transport, particularly from the rail and maritime sector, and we want to just vet these ontologies that have been produced off active data models with yourselves. So key takeaways. From my perspective and many of the 4D community in the UK, if you want interoperability, you must choose a top level approach for your data modeling. They don't mix and match well. Some people are trying, but it is quite a heavy commitment when you get to this stage. The layering ontologies and dependencies isn't as fixed as some people like to think, but it is a case of choosing an existing foundation data model like IES, HQDM, and others, will give you a lot of benefits. So if you don't want to understand the top level, just choose a foundation data model and get started. And please don't arbitrarily come up with an ontology. Explore your existing data sources, because they are the best representation of your organization and all of its interfaces. Start an active problem and work out from there, and you'll see the benefits of interoperability. Thank you much.
I'm thinking that the art form is making wise choices as what goes into which layer, the clustering. How do you advise people to make good choices so it stand the test of time? I feel this is for you, Jonathan.
The reasons for the heavyweight commitment at the top is that even if teams are independently making ontologies, they are recognizably similar with the results. Currently with software practices, if we give the same set of arguably fictitious requirements most of the time to 5 different teams, they will come up with 10 different answers, very much with how different things approach. Really, with these heavyweight top level ontologies, they should be recognizably similar. So it is a little bit of an art form. It is more of an apprenticeship with ontologies and doing it and proving it out, and then gets you the experience of working with them. And you do start to form these natural clusters. But it is very much more of a sort of get a feel for it and only work with the active systems that have those problems. And then over time you can change. And that's the whole point of these models, is that actually it's not a must release a version 10 and that's all we're using. We were expecting these sort of conceptual models to evolve over time. But it's a case of looking at which layers make sense for that particular use case and then move forward from there.
Very good, thank you. Next question, Jonathan, again for yourself, is at the moment Transport Core has what you've put on screen, but broadening out from road, rail, maritime to maybe include paths, tracks, etc., to accommodate all travel and multimodal transports. So any thoughts on that at all?
Yeah, so as previously presented on the Gemini call, it's worth going back and looking at that recording, because Transport Core is much more than just those domains. It's just from my perspective of the presentation today, it's actively supporting the road, rail and maritime domains. Transport Core does include all of the other things you've mentioned there. So it's in terms of paths, tracks, active travel, multimodes, etc. Because at the moment they are fairly small extensions. So rather than having a small reference data library, in addition to Transport Core, we've just kept it all as Transport Core. Again, that was a choice. That's part to the sort of artistry just asked around in terms of how you make that separation. And for us, it was just a case of keep it in there for now. As we get active use of it and see it demonstrated, it may need to become its own reference data library. It can just stay quite happily in there, because active travel and multi-mode of transport is a really key part of transport, and hence a key part of the Transport Core overall.